Welcome to David Alexander Maths Tuition. This is Chapter 3B on quadratic simultaneous equations. Okay, so when we've got a quadratic simultaneous, so y equals x squared plus 2x minus 6, this is a curve. Now it's quite likely we will get two solutions, because if this is a straight line and this is a curve, a line might cut a curve in two places. It's possible it might only cut it in one place, in which case, well, it's not really cutting it, it's just touching it, and that would mean the line is a tangent to the curve. Now what we've got here is y equals some stuff and y equals some other stuff. So if y equals this and y also equals that, then this must equal that. So let's write that down. X squared plus 2x minus 6 equals negative 3x plus 8. I've got a quadratic equation. I need to make it equal 0. So to do that, I will add 3x to both sides. I will subtract 8 from both sides. Now I will factorise. That's going to be x plus 7, x minus 2. So x is negative 7 and x is positive 2. Now what are the y values? Well, y is negative 3x plus 8. Well, it's also x squared plus 2x minus 6, but I'm going to use this equation because it's much easier. So if x is 2, minus 3 times 2 is minus 6. Minus 6 plus 8 is 2. So when x is 2, y is 2. And when x is negative 7, minus 3 times minus 7 is 21. 21 plus 8 is 29. So I'm getting two solutions, and we can write these as coordinates. If these were plotted on as a graph, it would be, the intersections would be 2, 2 and negative 7, 29. Now for this next example, I can't do what I did for the first one. So what I'm going to do is, for this equation, the top one, I can easily make x the subject. In fact, I can easily make y the subject as well. So if x plus y is 8, then x is 8 minus y. So now in the harder equation, well, the one where we're multiplying x by y, I'm going to replace x with 8 take away y. So that's going to be 8 minus y, lots of y, equals 15. So expanding the brackets, that is going to be 8y minus y squared equals 15. So minus y squared plus 8y minus 15 equals 0. We don't really want a minus y squared, so let's flip the sign of everything. Basically, we're just multiplying the whole equation by negative 1. So positive y squared minus 8y plus 15 equals 0. So factors of 15, 5 and 3, that gives me 8, but it's y minus 5, y minus 3 equals 0. So our solutions for y are 5 and 3. And x multiplied by y is 15. So when y is 5, x is 15 divided by 5, which is 3. And when y is 3, x is 15 divided by 3, which is 5. And again, we can write these as coordinates 3, 5 and 5, 3. Okay. So here are a few more examples. So here we know that y is x squared plus 42. So all I'm going to do is replace y. Well, there's a few ways we could do this actually, but let's just do a substitution. We're going to replace the y in the top equation. We're going to write this y in terms of x. The reason we can't solve equations when there's two variables, so if we can eliminate one of the variables, so here we're eliminating the y and replacing it with some x's, then we can solve it. So that's 28 minus 2 lots of x squared plus 42. So 22x is 28 minus 2x squared minus 84. Okay, so I'm going to bring the negative 2x over to the other side. So that's plus 2x squared plus the 22x equals 28 minus 84. And 28 minus 84 is negative 56. So I'm going to move the 56 over to the other side. And I can divide this equation by 2, x squared plus 11x plus, what's half of 56? 28 equals 0. And now this factorises much more easily. X plus 7, x plus 4 equals 0. So x is negative 7, x is negative 4. And right, now we just need to, maybe I will use the bottom one. So y is this number squared plus 42. minus 7 squared is 49, 49 plus 42 is 91. And when x is minus 4 squared is 16, 16 plus 42 is 58. So we're getting two solutions there. Okay, so for this final example here, it's much easier for me to make x the subject than it is to make y the subject. So x is 13, take away 3y. So if x is 11 minus 3y, then x squared is going to be 11 minus 3y squared. So I'm substituting some y's for some x's. So let's continue with this equation. Plus y squared equals 13. Let's expand the brackets. 1, 2, 1 minus 33 minus 66y plus 9y squared plus 1y squared is 13. So 10y squared minus 66y plus 1, 2, 1 equals 13. That's going to be 10y squared, take away 66y. What's 121 take away 13? It is 108. That's still positive. Equals 0. Okay, so I can definitely divide through by 2. So 5y squared minus 33y plus 54 equals 0. And here I'm just going to use my quadratic equation solver. So I know that a is 5, b is negative 33, and c is 54. So 5y squared minus 33y plus 54. So y is 18 over 5 and y is 3. Okay, so now x is 11 minus 3y. So 3, if y is 3, then 3y is 9. 11 minus 9 is 2, so y is 3, x is 2. And 18 over 5, I'm going to multiply that by 3. So that's 54 over 5. Subtract that from 11, so 11 minus the 54 over 5, x is 1/5. And again, we could write these as coordinates, so 2, 3, and 1/5, 18/5. So sometimes these ones can be quite complicated, but all you need to do is get one equation in terms of x, or maybe y, and then substitute it into the other equation.